In this video, we're going to look at the 5-number summaries and box plots. So what I have here in front of you is a set of data that represents the annual number of miles driven for a sample of cars. And these numbers are in the thousands. So of this set of 15 samples, they range from 3,300 miles driven in a car per year up to 16,700 miles. And the first thing we're going to do is come up with our 5-number summary. In statistics, our 5-number summary is simply your minimum value, quartile 1, quartile 2, quartile 3, and the maximum value of your data set. So for this particular set of data, I've already placed it in order for you from smallest to largest. So that, of course, would be the first thing you would need to do when looking at a set of data. Your minimum value is clearly 3.3, and your maximum value is 16.7. Now, for the quartiles. Quartile 2, you know as the median. This is the median of your entire data set. So, for this particular data set, we have an odd number of values. So our median comes out to be exactly 12.2. Now, of course, if you had an even set of values, you would need to take the two middle values and find the average. And that would represent your median or quartile 2. But in this case, our median is simply 12.2. Now, quartile 1 is going to represent the median of the first half of your data. And quartile 3 is going to be the median of your second half of the data. And this is how we come up with our 3 quartile values. And these quartile values essentially split your data into 4 equal parts. So to come up with quartile 1, now our book utilizes what's known as the 2-key method for developing 5-number summaries. And what the book does is, and what that method is actually means that this median value needs to be included in both the bottom half and the top half of the data. So that value does influence what your quartile 1 is and what quartile 3 is. And I want you to be careful here, because those of you that are proficient with your graphing calculator does not use this particular approach. What your graphing calculator will do is, once the 12.2 is used as the median, it'll leave that value out, meaning it'll find quartile 1 only from values 3.3 to 11.9. I'm going to go through this problem in the exact way that the textbook and my stat lab does it, which means I'm going to include the 12.2 in both the top and the bottom half. So when we go to calculate quartile 1, we need to use the values from 3.3 to 12.2, which gives us 1, 2, 3, 4, 5, 6, 8 values to work with. So what we need to do is go directly between 10.7 and 11.3 and find that average. And right between 10.7 and 11.3, of course, is the number 11. Now, to find quartile 3, the 12.2 is now, we use values 12.2 up to 16.7. Again, we have 8 values. So in this case, we need to go between our 4th and 5th, which is 13.6 and 14.8, and that gives us a quartile of 14.2 for quartile 3. Now, as you can imagine, you can easily see now how if the 12.2 is not used in those two halves of data, you're going to have different values for quartile 1, quartile 3. So again, if you're using your graphing calculator, you will get slightly different numbers there. So now, we're going to turn this, we're going to use these values and make what we call a box plot. In order to do that, we first need to determine if there are any outliers. To find our outliers, first we need to find what's called the interquartile range. Now, all these formulas are on your formula sheet. The interquartile range is simply the difference between Quartile 3 and Quartile 1. So in this case, it's 14.2 minus 11. So our interquartile range comes out to 3.2. That interquartile range is used to determine our lower limit and our upper limit. Sorry, it should be an L. And our upper limit of our data sets. And these will help us to find outliers. So the lower limit is Quartile 1 minus 1.5 times the interquartile range. So it's 11 minus 1.5 times 3.2, and if you do that math, you get 6.2. Now let's find the upper limit of our data. This, of course, was Quartile 1, and this is going to be Quartile 3 plus 1.5 times the interquartile range. Again, all these formulas are on your formula sheet, and as I said in the past video, please have that formula sheet out in front of you as you're working, because that is what you are going to have to rely on for your test, and it will be better if you know where everything is and how to use those formulas. So we're going to take 14.2 plus 1.5 of the IQR, and we get a value of 19. So what exactly does this mean now? Since our lower limit is 6.2, any data value that is lower than 6.2 is considered a potential outlier. And again, it'll be up to the researcher to further investigate if it's a true outlier or not, but right now we're just looking for potential outliers. And then any data value that is, above the 19 is also a potential outlier. I'm just going to go ahead and get rid of that little mess real quick. Sorry about that. And let me come over here. So now let's look at our data and decide, do we have any data values below 6.2? Well, absolutely, we have one. So that 3.3 is a potential outlier. And we're going to represent that in our box plot as an outlier. And do we have any data values above 19? No. So we have no outliers that are above the data set. Okay. Let's go ahead now and use our 5-number summaries and our outliers, potential outliers we found, to form our box plot. The first thing you want to do is make an accurate interval and to label it. So for this particular box plot, again, these were annual miles driven, so I'm going to label it annual miles. And you should also give the units. This was in thousands. Okay. And you're going to draw a line that we're going to put our scale on. Please carefully draw it to scale. Figure out a scale and draw it as neatly as possible. Don't just put the 5-number summaries in equal intervals. So our data goes from, 0 to 20 is a good scale for this particular set of data. So we're going to start at 0, and I'm going to check off N1s, 2, 3, 4, and I'll put every 5, 6, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So to start, I would always start with the quartile 1 and quartile 3. That's how you're going to draw your box. Your box is going to start at quartile 1 and end at quartile 3. So that is going to start at 11, and it's going to end at 14.2. You're going to draw a box from 11 to 14.2. The median value, which quartile 2, the 12.2, is going to be a line in the middle of your box. So there's 12, so 12.2 is going to be about right there. And that's going to represent your median. Now, the whiskers of the box. So here, for the lower limit, if you recall, we had a lower limit of 6.2, which means 3.3 was an outlier. So I can't draw a whisker down to 3.3. So we look up at our data set again, and what is the next data value after 3.3? 8.7. So we're going to draw our whisker down to 8.7, so right about there. Okay, now that doesn't mean we don't represent 3.3. It was still a data value. We need to represent it. We're going to represent it on this graph as an asterisk at about 3.3. We didn't have any outliers on the upper end of the data, so we can go ahead to our maximum value of 16.7, about right there. Okay, and there you have a box and whisker taken from your 5-number summaries with a potential outlier. Thank you.